Okay, so this is our last lab. This goes with the non-parametric statistics that we learned about in chapter 12. So the first question says, let's test for a difference between this reported and this measured height for, now it's really important that when we put these in, that this is one, this is one, this is one. Notice they start scooting over just a little bit. The 72 goes with this one down here. Let me show you on the Minitab. Okay, so I have the reported heights and the measured heights. There's 12 of them in each. So make sure that when you type them in, you keep them straight. You know, put them in one at a time so that they match with each other because they're paired together. This is paired data. Now to do the sign test, we're going to have to calculate this difference. But I don't have to actually do 68 minus 67.9 and 71 minus 69.9 because Minitab will do this difference for me. Let me show you how. Go to Calculator, and then I'm going to store the result in C3, right? I stored the result in C3, and I did reported, and I did minus, measured, just double-clicked it in, and clicked OK. And I got the differences here. Then I'm going to go to Stat, Non-Parametric, and I want to do a one-sample sign test. So I do the sign test on the difference. And I'm testing that the difference is 0. If there is no difference between the reported and the measured height, then the median would be different. Now notice we're testing the medians now, not the mean. And I just want to see if they are different from each other. So that's not equal to. And then I clicked OK. And I got my sign test for the median difference. And my p-value is 0.7744, which tells me that there is no difference. That p-value is significantly higher than 0.05. So there was no difference. And our conclusion is do not reject the null hypothesis. Now remember, the hypotheses now are using the word median, not the mean. For number 2, we're going to test this body temperature against a median of 98.6. So the first thing I had to do was enter all this data in. I'm going to use the Wilcoxon sign rank test. So let me show that to you. So I entered in these temperatures, right? That are on the lab. Then I go to Stat, Non-Parametric. One sample Wilcoxon is the same thing as the Wilcoxon sign rank test. I went here, I clicked in temperature, I entered in my test median of 98.6, just like the lab said, and I'm checking that the median is less than this value, so I changed my alternative to less. And then my Wilcoxon sign rank test, my test statistic is 3.5. My p-value is 0.005. So I do reject the null hypothesis. There is enough evidence to suggest that the median temperature is less than 98.6. And if you're doing a Wilcoxon sign rank test and you had two values like this, you would have to do the same thing we did here, and you would still do the one sample Wilcoxon on the differences. All right, so the next question, I think you can handle some here. I think you can do this one by yourself, and you can do this one by yourself. Don't forget you put in the before in one column, you do the after in another column. Then you're going to go to Calc and Calculator, and then the first empty that you have, first empty column, you're going to put the difference, and it's going to be before minus after, and Minitab will do the differences for you, and then you do the Wilcoxon sign rank test on the difference. And if you're comparing two things, then the test median would be 0. Now this one are two independent samples, so I ended up having to put both of them in to two different columns, right? The OCD patients and the control patients, and I was looking for brain volume. We looked at this exact same data set when we were doing parametric and we were doing a two-sample t-test. But now we're going to do the Wilcoxon rank sum test, which is a non-parametric test. All right, so the Wilcoxon rank sum test in Minitab is also known as Mann-Whitney. So when it tells you to do Wilcoxon rank sum, That means to do Mann-Whitney. So I put in, first sample was the OCD patients, sample 2 was the control patients. I'm doing a not equal just to see if they're different. And here is that data set, the Mann-Whitney test. Here is my test statistic, the 96.5, and my is significant at, this is my p-value, 0.0022. So that's significantly less than 0.05, and thus we would reject the null hypothesis. There is enough evidence to suggest that there's a difference in the brain volume between these two groups. All right. And the last problem to try is this one. Anytime the nonparametric equivalent of the ANOVA test is known as the Kruskal-Wallis test. And so what we have to enter it in, when we did the ANOVA test, we entered these into 4 separate columns. But to do the Kruskal-Wallis, we have to enter all the data into one column. Let me show you what I did. So over here, notice I had 1, 2, 3, 4, 5 subcompacts, 5 compacts, 5 mid-size, and 5 full-size. So I have to list the word subcompact 5 times. Then the word compact 5 times, then mid-size 5 times, then full-size 5 times. Then here goes the 5 values that are listed on the Minitab lab, these values right here. I entered those into here. Then I did the same thing for compact, then I did the same thing for mid-size, and the same thing for full-size. So now I have everything in 2 columns. Notice once I change this to a Word, this -T means this is a text file now. To do the Kruskal-Wallis, I go to Stat, Non-Parametric, Kruskal-Wallis. My response needs to be the numbers. If you notice when I'm up here, when this is active, the size box doesn't even show up because that's a text box and this has to be a numeric box. But once I click here, my text box comes up of size. I click OK, and here I get the Kruskal-Wallis test. My test statistic is the H equals 1.19, and my p-value is 0.755. We did this exact same test when we did the ANOVA, and we came up with the exact same result. The p-value is different, and the test statistic is different, but the result is the same. This p is greater than the significance level, so we do not reject the null hypothesis. There is no difference between the medians of the 4 sizes. And the hypotheses for these all have to do with medians. So just like in the ANOVA, the null hypothesis is all the medians are the same, and the alternative is at least one of the medians is different. I know I did a lot of this lab for you, but I think it's still a good idea for you to go back and do this one again all by yourself, and this one again all by yourself, because come test time, you will be doing things like this, and you need to make sure that you get the same answers I got on the lecture. So if you go ahead and finish the lecture, if you have any questions, please email me and I'll do my best to answer them. Thank you.